Over the next two lessons, I want to introduce you to a different way of thinking about cells in a spreadsheet. So far throughout the course, we've relied on a specific notation for cells that we've called A1 notation. A1 notation simply means that we use a letter to represent the column and a number to represent the row. For example, cell C4 or cell F2. The reason it's called A1 notation is because the top leftmost cell in our spreadsheet right here is cell A1. So the top leftmost cell and the way that we reference it is also where the notation gets its name. But this isn't the only way that we can actually think about references within our spreadsheet. If you take a moment to think about it, there's a lot of logical jumps that we make in Excel. For example, if I was working with a coworker and I had a value here in column A, and I said, put a value in the column that's 2 to the right, the coworker would intuitively understand that I mean column C. But how are they doing that? Well, they're looking at it from a logical perspective. But from a computer perspective, from a programming perspective, it doesn't really make sense because our column is A, and how do you represent the idea of 2 to the right of A? Right? A is a letter. So if we were to try to express this as a mathematical operation, it would be something like A plus 2, which doesn't really make any sense. So as you might guess, behind the scenes, Excel is actually looking at column A as column 1. If we look at that column as column 1, it becomes a lot easier to perform some kind of mathematical range movement. If we want to move 2 columns to the right, it's as simple as saying, we're in column 1, let's add 2, we're going to get 3, and so our final destination is going to be column 3. Believe it or not, behind the scenes, that's how Excel actually works. So what we see up here with these letters is actually just a mask. It's a layer above Excel's actual mathematical model. This is just presented to the user to offer a little bit of simplicity. But behind the scenes, the columns are also represented as numbers, and that's exactly what R1C1 notation is. R1C1 notation is just a different way of thinking about range references. In this notation, we use a number to represent both the row and the column. The reason it's called R1C1 is because in this syntax, the top leftmost cell right here is row 1, R1, and the column is column 1 or C1. So that's where we get the name R1C1. As it turns out, we can actually enable a setting in Excel to bring us into this view of R1C1 where all of our columns will be represented as numbers. So we can see how Excel is actually working behind the scenes. It's pretty simple. All we have to do is go into File right here, then Options, and on this Excel options box that pops up, there's going to be a Formulas tab. And under this section, Working with Formulas, we have an R1C1 reference style button. If I click that and then click OK, you'll notice that the columns are now going to be represented as numbers. Now, this doesn't just change the visual look of Excel, it also changes how we have to write formulas within our actual cells in our spreadsheet. So for example, let's say I put a value right here. In row 4, column 2, let's just say I write the value hello. Let's say I want to reference this value from another cell. Let's say any random cell like right here in row 10, column 8. Well, normally I would write something like row 4, column 2 in the actual A1 notation, which would be B4. But now we don't have the concept of B, so something like this is simply not going to work. We basically turn that option off when we enable this R1C1 setting. So the first thing that you have to know about R1C1 is that the way that we reference a absolute cell, so a kind of a deterministic reference to an explicit specific cell, is by writing the actual numbers after the R and C letters. What I mean by this is if I want to reference that cell, I begin with the letter R, that represents the row that I want to capture. And in this case, it's row number 4. And you can see that the blue highlighting box has now appeared to show exactly what it is that I'm targeting. After that, we put C, that represents the column. And then after C, we put the actual number of the column that we want to reference. So in this case, it's going to be column 2. So if we have a syntax like this, equals R4C2, row 4, column 2, that's going to get us the value hello. So that's how you make absolute references in R1C1 notation. The real benefit of R1C1 notation, however, comes from relative references. Let's just dive into a few examples in this lesson, and then in the next one I'll show you an actual example with a real-life problem that you might face. So what I'm going to do here is just clear this content, and let me go ahead and place a random value in one of these cells. Let's just say row number 6, column number 4. I'm just going to write a value like 5. And what I want to do here, after I just make it a little bit more definitive, let's bold it, center it both ways. Let's say I want to reference this cell from a bunch of cells around it, but this time I don't just want to use the absolute reference of R6C4. I want to target it relatively from where I currently am. So for example, let's say I'm going to start in this cell right here, row 4, column 4. The syntax is going to look like this. I'll begin with my equal sign, and I'm still going to begin with my R here. And what I need to do here is I need to move downwards. And the way I do that is with actually square brackets. So I can't just write number 2 here, because if I write number 2, then it's going to interpret it as row 2. But if I put square brackets, the number in here represents the number of rows that I want to move downwards. So if I put 2 here, what this means is 2 down from the current row. So now you can see we're highlighting the proper row, row 6. Now, how do I stay in the same column? Well, if I just do C by itself, we could do something like write the manual reference of C4, but there's really no need to do that because it's going to be less dynamic. If we write just the letter C, the way this works is it's going to know the column you're in and it's going to substitute it. So just the letter C means the current column. So this syntax is again going to go 2 rows down, same column, and it's going to reference the value in that cell. So we're going to get a 5 in there as well. We've copied that value. Let's take a look at another example. This time I'm just going to navigate a little bit below, maybe 3 cells below. And once again, we're going to begin with an equal sign, just to do a few more practice runs. We're going to begin with R, but this time we want to navigate upwards relative from where we are. So we know that whenever we want to navigate, we always have to do the square brackets, otherwise it's going to be a literal reference. But this time, if we put a positive number, we're going to move downwards. So in order to move upwards or backwards, you actually have to provide a negative number. We want to move 3 rows up, so we have to provide a value of -3. Once I close this, you can see the right row is highlighted, and now we still want to stay in the exact same column, so I can just put the single letter C, and that's going to target the 5 in this cell and represent it right here as well. 2 more examples. Let's attack this number from both the west side and the east side. Let's say I start right here in row 6, column 1. Once again, we're going to put an equal sign. Now this one is a little bit different because now we have the situation reversed. We want to get the value that's currently it's number 5, but we want to stay in the current row. So now when I write R, I'm not actually going to write anything afterwards, neither a number nor a square bracket with a number, because that would be either an absolute reference or a relative movement. In this case, I want to stay in the exact same row. So this is done. However, when it comes to columns, this time around, I do need to provide something to columns in order to actually move to where I want to go. And again, I can provide C4 here to target column 4, but I want this to be dynamic. So how can I actually move? Well, I want to move 3 columns over, from column 1 to column 3, and then it simply becomes a mathematical calculation. If I want to end up in 4 and I'm currently in 1, I have to move 3 over. So I can provide a positive value of 3. 3 in square brackets when it comes to columns means rightwards, and when I execute this, we're going to get the exact same result. One more example right here. Let's say I move somewhere immediately to the right of my original cell. Same idea. We're going to use R here to stay in the same row. We're going to use C, and we want to move now backwards. And it's the exact same logic as moving upwards when it comes to rows. Whenever we want to move leftwards with columns or backwards, we have to provide a negative argument. In this case, I want to move 1 to the left. And again, the way you can think of this is I'm in column number 5. How do I get to 4? 5 minus 1. So you can think of it as a mathematical expression like Excel does. And when I execute this, we're going to get the exact same value. So in this lesson, that's really all there is to cover here. We talked about the R1C1 notation and the different ways that we can reference cells within R1C1 notation. We talked about absolute references. In that case, all we do is we just write R followed by the number of the row, and then C followed by the number of the column. We can also leave either R by itself or C by itself. That's going to reference the current row and the current column. And finally, we have that square bracket notation, which is a dynamic relative movement. So a positive value for rows means downwards, a negative value means upwards, and a positive value for columns means rightwards, and a negative value means leftwards. It's a lot to take in, so I recommend you do an exercise like this. Just put a value somewhere randomly in this sheet, find some random cells around it, and see how you can navigate to that cell. In this lesson, we kind of take a look at some of the basic examples, but try an example where you have to provide negative arguments to both R and C, or positive arguments to both, or swapped arguments, negative, positive, positive, negative, etc. In the next lesson, we're going to take a look at how we can apply this to a real-life math problem, or a real-life Excel problem rather, and you'll see some of the benefits of R1C1 notation, especially as compared to A1. I'll see you there.